Welcome back, Algebra 1 Superstars. We're in the middle of our Topic 2, which focuses on linear equations, equations that create lines when they're graphed. Today is lesson 2.3, which is going to be linear equations in HK form. Last class we learned about linear equations that were in slope-intercept form. This class is just going to take us a little bit further. So we're going to start by actually reviewing a little bit about slope-intercept form and trying to extend on that knowledge. Please go ahead and work A, B, and C. Your goal is to graph each of these equations, making sure you remembered what we did last class, and then we'll come back and discuss them once you're done. Ready, set, go. Alright, we need to remember that slope-intercept form is that y equals m times x plus b, where m is our slope and b is our y-intercept, hence slope-intercept form. Our first problem, if I wanted to match this up, y equals mx plus b, we can see the m, no problem, but the b, we discussed last class, we'll need that invisible plus 0. So that tells me my m, which is the slope, is 2, which we can always write as a fraction over 1, and then b, which is my y-intercept, right? The 0 is always in the x for the y-intercept, and then this green 0 is over here. So we start at 0, 0, and we use our slope to go up to right 1. That's going to give us another point, and we can continue the pattern from here. We're moving a little faster today because we just did this last class and you got a bunch of practice in. So, ended up here, nothing bad. Let's try our next one. Y equals 2x minus 2. Okay, our slope is going to be that 2 over 1. That tells us how to move, but we need a point first, and that's going to be key for today. Our point is this b value right here, and my b value will be the point 0, negative 2. There's the beginning of our graph. Let's move up 2 and over 1, and we have something that looks like this. We should probably note that this is the same slope as the original equation, both 2 over 1, and as we've learned in the past, graphs that have the same slope are parallel. So if I were to graph this on the same coordinate plane, actually I should probably do this in a different color. If I were to graph this on the same coordinate plane as the first one, then we'd see that they are parallel, never touching, because they rise up at the same rate. Remember that a fancy name for slope is rate of change. Let's look at the last one. We again have a slope of 2, no surprise here, 2 over 1, again a parallel line, but this time our b value is 1. So the y-intercept is 1, x is always 0. 0, 1, and then we use our slope. We go up 2 to the right 1 to get up here, and so on, so forth. Just working backwards. And we again have our marvelous linear equation. Okay, if a linear equation is in the form of y equals mx plus b, as every one we've seen so far is, we say that the b value, aka also known as the y-intercept, translates or shifts or moves our equation vertically. So what do I mean about this? Well, for example, in part A, b equals 0, right? Do we see the 0 that was up here? And so then we say that our equation y equals 2x was shifted 0 units up or down. But in part B, let's compare the graph that's here in yellow to the graph that we did in A that's in blue. I'm going to quickly put the part A graph down here. It looks something like this. If you think about these nice points on part A, and you compare them to their corresponding points on part B. When I say corresponding, we mean the same x value. So at an x of 1, there are 2 points here. How would you compare them? Well, the blue graph has been shifted down 2 points to get to the yellow graph. Every point, if you pulled it down or moved it down or shifted it down, you have to move each of them down by 2. And so on part B, notice that our y-intercept, our b value, was negative 2. And so instead of thinking of it as the y-intercept, we can actually think of that as a value that translated our graph in A 2 units down. In a similar idea, if we go back to that y equals 2x, our original equation from part A, regraphing this, we can see it's parallel, it's very close but never quite touches. And you compare the blue graph to the purple one takes every point on the blue graph and pulls it up. It looks like just up by 1 unit. And it shouldn't surprise you then that the b value is 1, which means that the function y equals 2x was moved up 1 unit. So another way to think about that b value is instead of the y-intercept, it vertically translates or vertically shifts or vertically moves an equation, right? We take just the piece with the slope, this part, and say that's my original equation. And then the value at the end is going to shift y equals 2x up or down. That's going to become very important today. But let's go ahead and just see that a little bit more visually. I'm going to pull up the Desmos graphing calculator. I made the comment a few videos ago that I really like the Desmos scientific calculator, but my love affair with Desmos goes a little further than that. I also really like their graphing calculator. The difference between a graphing calculator and a scientific calculator is, of course, in the name. A graphing calculator has the ability to graph equations. It can also do calculations. So if I do 2 plus 3 on here, it will tell you the answer is 5, but we go further than that. So what I'm going to do is I'm going to graph the equation y equals 2x plus b. 2x plus b. Now, Desmos can only graph equations with x and y. Adding an extra variable confuses it. So it says, well, maybe you think, or maybe we should change that variable to a number. So I'm going to add a slider. This slider says b equals 1. I'm actually going to go ahead and set b equal to 0 here by sliding this over to 0. Okay? And then I'm going to make a couple other changes. Instead of y equals 2x plus b, I'm actually going to go ahead and graph this as, and this is some advanced stuff, f of x equals 2x plus b. You'll learn about this notation in the next unit. It's just a different way to write y equals for now. And then I'm also going to create a point. I'm going to create a point on this red graph, 1, so that is over 1, and then up to the graph. But again, I'm going to use my fancy notation. This is called function notation. And what this is going to do is it's going to keep the point attached to the graph for an x value of 1. So when I set b equal to 0, this is going to cause us to see a point on the graph y equals 2x, not plus b, but plus 0. b is 0. And our current point right now is over 1 up 2. I'm going to go ahead and move the slider b, and we're going to try to explain what happens to the point we see on the graph. So watch this point. Let's try and describe its movement. I'm going to slide this to the right, like so. I'm going to slide it to the left. What is happening to that point on our line? Well, can we see that the point is traveling vertically? Right? It moves up and down. Because what I'm doing is I'm changing the b value, which is technically the y-intercept, but we also said the b is responsible for vertically translating our graph. So what happens to the point you see on the graph? Well, we say that the point moves vertically. Right? Vertically looks like this. All right. Now I'm going to go ahead and set b equal to 0. We'll leave it right there. There we go. And I'm going to go ahead and make a new slider, m. Currently, my m is 1. So it's a slope of up 1 over 1. Can you see up 1 over 1, up 1 over 1 on our graph? Okay, I'm going to go ahead and move the slider for m. As I make the slope bigger, what should happen to my line? Well, the slope controls the steepness, so I bet it would get steeper. And look, it does. It gets steeper, 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 steeper. There is 10, right? I ran out of room here, but if I made it 100 or 1,000,000, it gets steeper and steeper and steeper until it's almost straight up and down. But remember, straight up and down, we said, is an undefined slope. Technically, it's just the largest possible slope that you can think of. It's infinitely large, so sometimes when people say it's an infinite slope, they're not wrong. But since infinity is not actually a number, it just means really big, we usually just say if it goes straight up and down, it's undefined. What if I went the other way? It's getting less steep, less steep, less steep. There's my point again. Less steep, less steep. We're in the decimals between 0 and 1. What happens when I get to 0? Oh, we know this. There's no slope, and so the line is horizontal. Can I keep going? Sure. Now we're getting more and more steep, but we're getting negatively steep this time. We're moving negative steepness all the way down here, and there we go. Okay. All right. Well, what happens when you move the slider for m? It adjusts the steepness. Now, that's kind of strange because we were able to move this point not horizontally. Whoops. We were able to move this point vertically by moving the slider for b. b adjusts the vertical movement. And we were also able to adjust the slope of our line by moving m. But don't we have a direction of movement that's missing? We're able to move vertically up and down, but how would we move that point horizontally? And so what we're going to do today is we're going to look at a slightly different form of a line that will allow us to move our graph not only vertically, but also horizontally. You might be thinking, well, why do we care about that? Well, eventually it's going to become very, very useful to move any graph left and right and up and down. And so we just are trying to learn about all the tools that we'll have at our disposal. Let's go ahead and move on to the next page. Translating lines, aka HK form. Alright, so as we mentioned, we can translate lines vertically, that's adjusting b, and we can also adjust the slope, that's changing m, but we don't have an easy way to shift horizontally. Luckily, we're just going to adjust our slope-intercept form into a, what I think, I might be kind of biased, into a better equation for a line. This form is written as y equals m parentheses x minus h, close your parentheses, plus k. This is a form of a line that you should probably memorize. We use it all the way up through calculus and beyond. We, at least this year, will give it to you on your test, but hopefully you'll memorize this. I think it'll make your life easier. This form is commonly referred to as HK form, not a surprise because it has the letters H and K in it, or sometimes translation form. So let's see what we can do. First thing I'm going to give you is an equation and a matching graph, right? This equation, when you graph it, makes this linear equation. And this equation, when you graph it, makes that linear graph, and so on and so forth. Underneath each of these, you have a list of things you'll need to do. First, you'll need to list every, quote, nice, end quote, point on the line. We've covered this before. You go through, and you just list all of the nice points. Right? And we are actually going to list them here. So this one has 6 nice points. I'm literally going to list all of them. So this first one is -3, -5, and then we have -2, -3. Should make that look better. And so on and so forth. So I'm going to list all 6 of those. You have to calculate the slope, and then you're going to make connections. You're going to look at the slope and think, does anything in this equation match the slope? And then you're going to look at the points that you listed up here and think, do any of the points match the equation? So go ahead, take a few minutes, try this for all 3 of these, and then you can come back and watch me go through it and see how you did. Ready, set, go. All right. Hopefully you found some success here. I'm going to take quite a bit to do this just because it's going to take me longer to write out all of these points. Hopefully you're skimming through this to find where I actually talk about the good stuff and you're checking your answers here. There we go. We need to list the slope. Slope-wise, it looks like we're going up to and over 1. So my slope is up to over 1 or just 2. Let's make these connections. What is the connection between my slope and the equation below? Well, it looks like there's a 2 that's multiplying outside the parentheses. Okay. What's the connection between one of the points you listed and your equation? Well, looking up here, I don't see a 5 in my equation. I do see a, sorry for the yawn, I do see a 0, well, I don't see a 0, and I don't really see a 1 either. I see a -1, so maybe that's a possibility. I do see a 1 and a 3. There's a 1 and a 3 there. There's kind of a 2 and a 3, I guess. Two ones together, maybe a 2 and a 5 is out. There's no 5 in there. So maybe looking at those 3, it seems like there's connections, a bunch of 1s, a couple 3s. Then I do see a 1 and a 3 here. Okay, so we'll come back to that one. Let's look at our next one. All right, nice points. Oof, there are a ton of nice points on here, aren't there? That is going to take quite some time to write. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points, I got this. -5, 4. Let's even see if we can see a pattern for the x's just to make this easier. -5, 4. This one's -4, 3. I already see the pattern, right? We make one of these negative, and then we make the other one positive, but one smaller. So this will be -2, 1, and then -1, 0. Let's double check. That looks good. Then we continue. We keep dropping this or increasing this one. So 0. And then what's going to happen here? -1, right? The y's are dropping. So then we have -1, -2, -2, -3, -3, -4, and -4, -5 is our last one. Oops, not negatives though. Haha, these should be positives. I said they were increasing and then I didn't increase them. 1, 2, 3, and 4. There we go. So it finishes with 4, -5. Woof, there's all 10 points. All right, let's find the slope of our line. Slope looks like it goes down 1 to the right 1. So m equals -1 over 1, which is just -1. Okay. Do we see a connection? Well, I don't see a -1, but if we look over here, this was the number out front. Oh, we could put the invisible 1 here. And so it looks like the slope is again outside the parentheses multiplying. All right, now let's go ahead and connect that point. So looking up here, let's see what numbers match in here. Well, I don't see any 5s or 4s. There's a 3, but no 4. 3 and 2 is in there. That looks good. 2 and 1 could have to do with the slope. 1 and 0. Now we're going to try and match both numbers here. So 1 and 2 could be there. 2 and 3, not 3 and 4, 4 and 5. So we're getting a little closer here. We kind of see that we could do both of these numbers, right? We see those, and I'll try to maybe outline this in green. 2 and 3 showed up here and here. And then 1 and 2, if we think about this one in blue here, 1 and 2 showed up with those two. All right, let's look at one more and see if this can crack the case wide open. We have some important points. Looks like one here, here, and here. Not bad. So only 3 points this time. Nice. -3, 1, 0, 2, and 3, 3. All right. List the slope of the line as a fraction. It looks like we go up 1 and over 1, 2, 3. So my slope is 1/3. Nice. And notice that the slope matches. I think we're pretty good there. But then the last thing we need to do is match the point. So let's look at these. 0, 2 doesn't appear here. They're kind of 2 3s here, but it's weird as a fraction. I think -3, 1 is probably going to be our connection. Now, can we do that on each time? Notice that the 1 is positive and the 1 out here is positive. This 3 is negative though, and this one's positive. So it looks like the x was the opposite and the y was the same. Does that happen down here? Well, let's see. I see a -3, that matches, and then notice that the x is the opposite. So that one matches there too. Does this happen over here? If the x is the opposite, I'm looking for +1. I see a +1 up here. And then the y matches. Yeah, I think we have a pattern. It seems like a point that is on each of our lines matches the HK. But it looks like the x is the opposite number every time. All right, so at the end, given a linear equation in HK form, the x and the y are the variables. We're used to having x and y in our equation. We want to know, though, what do m, h, and k do? Well, the m has not changed. It is technically multiplying by x, so the m stands for the slope, or the movement, if you want. The h and k, though, if you put them together, create a point that's on your line. So just like y equals mx plus b, we are given a point and a slope. So let's go through and see what we can do here. Graphing HK form is actually very, very similar to graphing slope-intercept form. Let's compare the two quickly. Slope-intercept form. The equation is that y equals m times x plus b. To graph this, we plot the point that's given in our equation. The point in our equation is the b value, which is like the y-intercept, and you plot the point 0, comma b. That's how you plot every y-intercept. The x is 0, b goes on the y-axis. Once you have that one point plotted, you need more points, and so we use the slope, which is m, to plot more points. This says graphing slope-intercept form because I don't know how to use copy and paste. Really, this should say graphing HK form. And we can go through and rewrite that equation. Y equals m times the parentheses x minus h plus k. And let's go through and get this done. We need to plot the point given in the equation, and we said that if you combine h and k, it makes the point. However, we should notice that this negative h was always the opposite. It appeared to be the opposite, and then k matched the sign at the end. So we start at whatever this point is. It might not be the y-intercept this time. Then we use the slope m to plot more points. So it's the same process, just one equation, the slope-intercept, only gives us the y-intercept. The other equation may give us a different point, but we still use that point and then the slope to graph more. Now you'll notice this point has a little asterisk next to it, and let's read that note down below. In HK form, the h from the point HK will look like the opposite value in your equation. And this is really the only thing that I find throws off students. The reason it looks like the opposite is due to the negative that's in the actual equation. For example, if you have the equation y equals 2, 2 is the slope, that's the m, x plus 3 plus 4, the h value is the opposite of what it looks like here. The h value is negative 3. And that's because if you had an h of negative 3 and you put it into your HK form, right? I'm going to just go ahead in HK form and I'm going to replace just the h, not the negative, not the x, just the h. And so if you replace the h with negative 3, it looks like this. What happens when you have two negatives right next to each other? Well, those two negatives turn into a positive. And so because there's a negative in our equation, it's going to make the h value always look like the opposite. So let's get some practice in. And I think this will make sense. I'm really just going to try one of these with you, then you guys should do the rest. It goes very, very quickly. It's very similar to slope-intercept form. So the first problem, y equals 1/2 parentheses x minus 1 plus 3. Let's identify the slope. Well, that's nice. It's right out front. Up 1, to the right 2. HK. The easy part with HK is the k value just stays whatever it is. If it's positive 3, it's 3. The tricky part, though, with HK is we need to do the opposite of what this number looks like. It looks like negative 1, so it will be positive 1. It's the opposite every time. Now let's graph it. HK over 1, up 3. Great. Slope up 1 over 2. Up 1 over 2, or go the other way. Down 1 over 2, down 1 over 2, and so on and so forth. Once we have those, we connect our points, and we should have our first line graphed from HK form. We should double check this slope is positive. My line has a positive slope. It's not very steep because 1/2 is not a very big number. At this point, please go ahead and pause me and try the rest of these. There are 5 more. I will go through these together with you once you unpause, but it kind of takes a while for me to talk you through it, so I'd rather you try it and then just skip forward, make sure your graphs are right, and you can go from there. Ready, set, go. All right. Well, the next thing I'm going to do is just write out all of our slopes and our HKs and then graph them after that. So it looks like my slope for the next one is 1/2, and 1/2 for the third, 1/2 for the fourth. What about the fifth and the sixth? Well, there's no number out front, so we can put that invisible 1 here. That's going to be -1. And then we always write slope as a fraction, so that looks good. And then this last one is kind of weird. Maybe we should come back to that one at the end. All right, HK. Well, H is always the opposite. It looks like +1, so that becomes a negative. And then we just use the 3 at the end. So that's the point, -1 up 1, 2, 3. Next one, H is the opposite, so +1, comma, -3. +1, -3 is over here. Fourth one, -1, -3, down here. Fifth one, well, this is clearly the H. It's inside parentheses. It's the opposite. But what's the K? Well, just like with slope-intercept form, if there's nothing outside the parentheses, we can certainly put a +0. And so we start at -2, 0. And now we get to this last weird one. This last weird one doesn't really seem to be HK form. I'm going to write HK form, we'll write it above it. Y equals mx minus h plus k. Well, the m, I bet you can guess, is probably going to be 2, and you are correct. But what's h, what's k? Is this 1 because it's next to the x, the h, or the k? Well, the giveaway is that h is always inside of parentheses. And I don't see any parentheses here. So what we're going to do is we're going to rewrite this with the 2 on the outside of parentheses, and we're going to put something in parentheses that won't change the problem. I'm going to say x minus 0 won't change the problem, because 2 times x, if you distribute, is 2x, and 2 times 0 is 0, so we don't even need to write it. This is the exact same as the 2x. But then you might be saying, well, what about the +1? Just put the +1 at the end. 2 times x is 2x, 2 times 0 we don't need to write, and then there's just the plain old 1 at the end. So this is actually HK form. We can do the opposite of -0, which is 0. Doesn't really matter. And then we have 1. So my point is 0, 1, and you were correct. The slope is up 2 over 1. Let's get each of these graphed. This should go pretty quickly. Slope is up 1 to the right 2, or left 2 down 1. Left 2 down 1. I find it easy just to kind of retrace the slopes we've already done. Once you fall into the pattern, you will find your equation. Okay. Next one over here, same thing. Up 1 over 2, practicing those slopes, like so. And we graph. Fourth one, up 1 over 2. And the graph. Fifth one, we finally have a different slope, down 1 over 1. Again, I always like to put the negative on the top. I can usually remember up and down pretty well, and that way for the bottom one, I just always go right. So down 1, right 1. And again, I covered this last class, but sometimes you'll go the wrong way, down 1, left 1. But if you connect these, isn't this line going in an upwards direction? It can't go in an upwards direction because it has a negative slope, and we know negative slopes go down this way. So I know I have to go down 1 to the right 1 to make the line go in a decreasing or downwards direction. Just quickly putting a bunch of guide dots on here, guide points, and we're going to go through and connect them like so. Last one, we found our starting point kind of hidden in here. We're going to use the slope to go up 2 over 1 or back 1 down 2, like so. And we connect one last time. Awesome. You guys are doing great. If you were comfortable with this, or if you're comfortable with this now, you've really done the important part for today. You've understood we have a form called HK form, which gives us the slope and a point. We are going to get some different practice in though, so stay with me. Here we go. You may have noticed that the last two equations had a few numbers missing. And just a reminder, don't forget that if you're multiplying and there's a missing number, you can always put in an invisible 1. If you're adding or subtracting, you can always write in an invisible 0. Adding 0 or subtracting 0 never changes a problem. In fact, can you see the connection between HK form and slope-intercept form? Right? We even did this on this last problem. This was in slope-intercept form. This had a y-intercept of 1 and a slope of 2. Well, I rewrote it as HK form by putting in the 0, but a y-intercept always has a 0. So if you ever have an equation that's in slope-intercept form, we can rewrite this by remembering that there are parentheses around the x, and so we can say x minus 0 and then plus b at the end. These two are exactly the same. X minus 0 is still x. And so that means that slope-intercept form, if you think about this in HK form, has the point 0, comma b, which we know, of course, is the y-intercept. All right, now we're going to go ahead and jump back to Desmos. All right, and I'm going to switch up what we had graphed before. Instead of looking at slope-intercept form, we're going to look at HK form. Okay, so we're going to go through, and I'm going to probably clear most of this out. And we're going to get this HK form in. So we're going to do x minus h plus k, and I meant to delete the rest of these. There we go. I'm going to add sliders for both h and k. And let's see what this problem tells me to do. First, what is the slope of my equation? Well, the slope of this equation, what invisible number is hiding out front? There's a 1, isn't there? So I think my slope is 1 over 1. We can always write in that invisible 1. Well, they did also ask us to graph the point h comma k, so I should probably do that too. H comma k. There we go. Take a look at that point. Looks pretty nice, doesn't it? And we're going to go ahead and we are going to mess around with the different sliders. First it says move the slider h. So right now, this equation, and I'm going to write it out down below, has x minus, currently the slider h is at 1. So this is x minus 1. And then this k value is also at 1, so plus 1. Notice that the green line is on top of the red line. This is what is currently graphed. Now I'm going to move this slider and let's see what happens to my equation. As I change h, right now h is 3, so this would be a 3 down here. What is happening to our graph? Well, it looks to me like our graph is moving horizontally. So h controls our horizontal movement. That was the missing piece that we didn't have in slope-intercept form. Right? If I bring h back to the original 1 that it was at, it doesn't have to be perfect, but I'll do my best. There's that 1. And move k. K is at the end, but we saw earlier that slope-intercept form b is just like k. It's sitting on the outside, and b moved our graph vertically. Let's see if that's still the case. Oh, there we go. As I move this, it moves our graph vertically. I can even hit play, and we can see this move up and down here. All right. So now we have two controls to our movement. H controls the horizontal movement, and K controls the vertical movement. All right. So what do we say then? We say that H translates, right, or moves or shifts our line horizontally. And that actually makes a lot of sense with the variable, right? If you're thinking about HK form, I like to think that the letter H stands for horizontal. It moves our graph side to side. K translates our graph vertically. You might notice that vertically does not have a K in it. So I make your English teachers cringe and I spell it differently. I say it moves your graph vertically, and instead of the C, I change it to a K. Don't tell your English teachers. All right, let's do a couple practice problems to finish off class. Problem 1. Stefan is given the equation for a line y equals 2x. Well, isn't that actually how we started today? We had the graph of 2x. Stefan wants to translate his line, so he starts to write this equation in HK form. He knows the slope is 2, that hasn't changed, but he groups x in parentheses so that he can add in an h and a k. The question is, which equation below will translate Stefan's line 3 units left and 4 units up? Well, don't forget that left and right is like h, that is the horizontal part. And then 4 units up, that's going to be like the k, which is the vertical part. So I think my h needs to be 3 and my k needs to be 4. But don't forget, in an HK form, we always want to make sure that it looks like the opposite. 3 units left would be like negative 3, so I actually need to make this a positive 3. Whatever number here, we will be doing the opposite. Does this match any of our answers? Yeah, I think it's this guy right here. This means move left 3 and up 4. Can you see why the others are wrong? Right, this minus 3 would actually mean move right 3. It's the opposite, up 4. Right 3, down 4. Left 3, down 4. So you can think of HK as a single point, right? This would be the point positive 3, negative 4. Or you can think of them as shifts or translations for this equation. Let's try another. Daniel is given the equation y equals 3 times x plus 1 minus 2. He excitedly tells his friend Patty that this line is parallel to y equals 3x. How does he know the lines are parallel? Well, I think all we have to do is compare the slopes, right? We know that y equals 3 times x plus 1 minus 2 has a slope of 3. We also know that y equals 3x has a slope of 3. Those are both the value multiplying by x. And we know that same slopes mean lines are parallel. We learned that on the very first day of topic 2. Let's try another. Which line is perpendicular to Daniel's line? How do you know? Well, the giveaway for perpendiculars, we're still looking at the slope. The slope is 3 over 1. But perpendicular lines have opposite. We should probably fill this in. So opposite means change the sign. 3 over 1. The opposite of 3 over 1 is negative 3 over 1. But we're not done there yet. It's opposite reciprocal slopes. And at this point, we should know the reciprocal of the fraction is the flipped over version. Opposite reciprocal. So which one of these has a slope of negative 1/3? Not that one, not that one, not that one. Oh, there it is. It's D, negative 1/3. The numbers at the end don't matter. In this case, they matched. That's great. They do not have to match. All right, last one. Brian wants to translate his equation of y equals x down 2 units and right 4 units. Write the equation of the line that accomplishes this. All right, y equals, what slope do I need? Well, I still want the original slope here. That's just 1. Down 2 units. Let's see, down 2 units, I think that's vertical movement. And vertical, let's see, vertical, that's the k value. I think that's over here. So down 2 units, we would need a minus and then a k. All right, well, what else do we need to move? Oh, not minus k, I'm sorry, minus 2. We also need to move right 4 units, right? If we're moving left and right, that's horizontal movement. That's the a value, or the, oof, I'm doing well. That is the h value. So h has to be 4. But I don't want it to be plus 4, because with HK form, we always do the opposite. So if I want to go right 4, it needs to look like the opposite. And that's it. So what do you need to do from today? Most important piece are these 6 graphs. You need to be able to be given an equation in HK form and create a graph. The point, don't forget the opposite of h comma k, and the slope. The second thing you need to connect is that HK form is really a clever way to move lines. If you have a line like y equals 2x and you want to move it left and right, you need to give it an h value. If you have y equals 2x and you want to move it up and down, you give it a k value. If you want to go through and move it both left, right, and up, down, you need both an h and a k. We're going to do a lot more with translating next semester, but it's always nice to see this early on. So thank you for tuning in to HK Form. Hopefully you got a lot out of this lesson, and we're going to move into next class for how to find x and y intercepts, and ultimately our very last lesson, 2.5, will teach us how to graph using x and y intercepts. Hopefully you have a great rest of your day.